A 99% of time estimates in geology are flawed. We rely on time, but our methods have fundamental cracks. Today, we explore the 3 biggest errors in dating deep time. A mistake 1. Misunderstanding the constant nature of decay. A radioactive decay relies on a fixed, unwavering half-life. If that rate changes, our entire timeline collapses instantly. The core assumption: no external forces affect this physics. But yet, high pressures or intense heat can subtly interfere. This contamination skews the calculated age upward or downward. But scientists must carefully choose mineral systems resistant to this alteration. Well, now that we understand decay fidelity, let's explore sequence. To a mistake 2 is confusing relative dating with absolute dating. The relative dating tells us which came first, the order of events. But index fossils act as temporal markers across vast distances. But relative methods provide no actual numerical age values. But absolute dating provides that number, usually through radiometric analysis. The mistake is assuming a layer dated absolutely is representative. Ice sediments are rarely deposited perfectly, creating gaps or overlaps. This is the hidden danger of unconformities, missing time. But dating the younger layer tells you nothing about the missing millions. The true understanding demands integrating both relative sequence and absolute numbers. Now that we understand sequence versus number, consider contamination. A mistake 3: failing to account for sample contamination. But this applies especially to carbon-14 dating limits and beyond. A carbon-14 is excellent for recent history, but has a boundary. Its practical limit hovers around 50,000 years maximum. In applying C14 to billion-year-old rock yields nonsensical results. A contamination occurs when foreign material mixes with the target sample. Even microscopic dust from the surface can invalidate millennia of data. This introduced material carries its own younger isotopic signature. The skilled geologist must use multiple dating systems simultaneously. When results converge across different clocks, confidence significantly increases. Igneous rock provides a great reset point for the geological clock. When magma crystallizes, the parent isotopes are essentially zeroed out. This allows us to date the actual cooling event precisely. However, hydrothermal alteration after emplacement can still cause issues. But chemical exchange introduces new isotopes, confusing the initial clean slate. Geologists must map the entire history, not just the rock itself. A single error in context leads to an entire chapter being misstated. But the scale of time we attempt to measure is truly astronomical. Every fossil, every layer, is a whisper across epochs. When dating sedimentary sequences, erosion complexity is another major pitfall. Conglomerates contain pieces eroded from vastly different time periods. But dating the cement gives the deposition time, not the class ages. This temporal mixing leads to wildly inaccurate age interpretations. When tracing the provenance of every grain becomes absolutely mandatory. Advanced instrumentation helps isolate the signature of the target material. We look for the outliers, the signals that don't belong together. But tectonic activity complicates matters further by recycling crustal material. Metamorphism heats and pressures older rocks, restarting internal clocks. The best geologists use stratigraphy to frame every analytical result. A context is the ultimate safeguard against these three fundamental errors. Avoiding decay rate errors requires trusting established nuclear physics constants. Avoiding sequence errors demands mapping every visible break and shift. And avoiding contamination means relentless testing of sample purity. These three mistakes represent pitfalls across all scales of deep time. Our understanding of Earth's history is built on vigilance. When each ancient layer tells a story, provided we read the footnotes. Respecting these limitations is the mark of a true geological scholar. Only then can we truly begin to grasp deep time's chronology.